Well, good morning, good afternoon, everyone, and welcome to today's webcast, Unveiling Secure Controllers for Efficient and Automated Operations. I'm Craig Fleming, Technical Editor of World Oil, and will be your moderator today. Artificial lift secure controllers are shaping the future of the oil and gas industry by enhancing operational efficiency and automation. Today's panel discussion will outline recent technological advances and the immense value-added potential of secure controllers. It will also present a thorough gap analysis for field automation. Discover how these systems enable operators to gain a comprehensive understanding of the critical IT cybersecurity requirements associated with these controllers. Joining us for today's webcast are Nick Stiles, Product Manager, and Franklin Curray, Global Product Manager, both from Baker Hughes. Nick is Product Manager for Baker Hughes' Production Link Edge system and is specialized in the application of edge computing in upstream oil and gas for the duration of his 13 years in the industry. In his previous roles within the company, he has spent significant time as a field engineer addressing the challenges of artificial lift production optimization facing operators in various regions internationally. Franklin is Global Product Manager for variable speed drives, downhole sensors, and upper completions at Baker Hughes. With over 18 years of experience in ESPs and hydraulic pumps, Franklin has worked in various roles, including operations, remote surveillance, and applications engineering. He is dedicated to assisting customers in reaching their goals using technology. Franklin holds a degree in electronics and control engineering from University in Quito, Ecuador. Before we get started, let's review a few housekeeping items. You can ask questions at any time during the discussion. Just type your question in the Q&A box located on the bottom left corner of your screen, then click the submit button. We'll ask the submitted questions at an appropriate time during the presentation. If you're experiencing problems with the program, press F5 on your keyboard to refresh the presentation. You can also visit the help guide by clicking on the help button below the slide window. Now let's get started with today's panel discussion. So Franklin, what are the current capabilities and challenges of existing controllers? Franklin, you there? Nick, you want to pick that one up while we wait for Franklin to reconnect?
Yes. Hey,
you back?
Yes, I'm back.
There he is. Okay, Franklin, so what are the current capabilities and challenges of existing controllers?
Okay, good morning, Craig. Good morning, everyone. It's an honor to be here. So going back to your question, in the artificial lift systems, there have been a lot of controllers deployed in the last 50 to 40 years. We can talk we go back a little bit in history. We started with fixed frequency controllers, that's known as switchboards, where the operation of the systems is just an on and off. And then we moved to variable speed drives, where we have better control of the systems, and production optimization is something that we were able to achieve. So the optimization and automation that we can do in the fixed frequency controllers is very limited. For instance, on ESPs, you only can open and close a valve at surface to be able to control the operation. So it's very elementary optimization that we can do. Then the variable speed drives start becoming a little bit more important to maximize the reliability of the systems as well as the production optimization, because we have the option with variable speed drives of changing the ESPs, and by that we can change the production of wells. So I would say today, my estimation is about 95% of the wells, of new wells, have a variable speed drive. So that really helps to be able to optimize the field operations. So this is very different from when I started, like 18 years ago, when I had to go and talk with the customers and explain why why it's important to have a BSD instead of switchboard. So today there is no question about the benefits of variable speed drives. So with the increase of variable speed drives, we also saw the need that we need to create better control systems, sensors, and also monitoring systems. Because with more drives being deployed and more oil fields being developed, we changed the applications from conventional to unconventional, heavy oil, solid, so but a big range of applications. So in the last decade, we see a big change in controllers. So the controllers became smarter. We were able to provide closed loop control algorithms to be able to control the flow rate based on the pump pressure, thinking like the cruise control that you have in your car. Or we change the speed based on the motor load. Then on the unconventional business, we start seeing more gassy applications where normally ESPs, or I would say probably any artificial lift systems, normally they don't like to be under those conditions. But with the controls at surface, we were able to extend the run life of those pumps. We have gas control software to be able to unlock gas locks on the pumps, and also being able to control the drawdown of those applications. So these algorithms help a lot in reliability and also optimization of the wells. However, if we want to talk about challenges, because of this mix of legacy and multiple brands that were deployed in over the last, I would say, 20 to 40 years, the capabilities of those controls will limit the optimization or automation that we can do in the oil field. And also it requires a vast amount of knowledge and experienced personnel to be able to set them up and optimize. So the installing technology as well as the people resources will limit the optimization and automation of these wells. Another challenge of these controllers is how they can integrate to monitoring systems. And, as I said, depending on the technology you have installed and also the communication protocol that you can use for that connectivity, this will limit the functionalities of remote monitoring and control that we have from SCADA systems. We use normally industrial protocols to communicate with the controllers in the oil field, and also serial communication interfaces. Even though these were considered long time ago safe, today, if with the cybersecurity and digitalization initiatives that we have, that will really limit what we can do in automation. And finally, there is limit remote serviceability. So majority of these controllers in the oil field require to have a person to be able to set them up, configure, and also update software. So it is required to have people resources inside to do that. So thank you, Craig.
Good deal, Frank, and thanks for all that input. So Nick, can you give us an overview of the ins and outs of how artificial lift automation is performed in the field today?
Yeah, thanks, and good morning, everyone. So I think there are two main areas that we see automation happening. And so from this diagram, you can see firstly at the left-hand side, there's the well side, and kind of to follow up on what Franklin said, there's lots of different control functions that we see happening there. Of course, varies across different lift types, different kinds of controllers, but in general, there's some control of physical things that are happening right there at the well site. The next area that we see some automation, and this is kind of, I think that you could kind of argue to what degree it can be classed as automation in this context. But if you look at the what I'll refer to as a central location where all the data comes back to that point, can be SCADA, can be a kind of a central surveillance location where people such as production engineers are doing analysis of data that's streaming in. They're interpreting trends, they're managing alerts, all that kind of workflows that you have to do to manage the operations in the field, and that can be quite laborious. So for example, a lot of manual analysis has to happen and still happens and that of course opens up areas to automate. So there are tools that we see that are again, it varies quite widely on what they are, but different techniques that we can use to assist the workflows of those users, and being able to surveil and analyze and determine the right decisions to make on the equipment that they're in charge of monitoring. So I think that those are the two main areas, but some kind of points to add on how this works right now is that when you look at the automation functionalities in each kind of zone, they're not really very well connected in the sense of, the automation routines that are going on. They tend to be kind of fairly isolated in the way that they interface. So, for example, we rarely see cases where you'll have a closed loop, as in without any human intervention, control command going back out from that central location out to the well site. It does happen, but typically it's quite a rare thing to see. I think that in general, how the data flows from the field up to that location, there's firstly various ways that it transmits, and lots of legacy systems in place that are doing that transmission. But a lot of vulnerabilities that are becoming more acute as companies tend to look at their overall infrastructure, start to look at new threats out there, and new kind of assessments of their overall production systems. But yeah, so those are the two kind of main areas that we see.
Good deal, Nick. Thanks for that input. So Franklin, how do existing monitor systems integrate in with these new type of controllers?
So to answer that question, so there are different monitoring systems that have been deployed. We can start with the PLC, the basic PLC based monitoring system. Normally, this is installed at the well site, where either there is one or multiple wells. But these systems only try to monitor if the pump is operating, and the facilities, they also are connected to the facilities, and provide a functional process safety. So very limiting from the automation standpoint and the optimization standpoint of the pumping system. As Nick mentioned, there are a handful of those where actually the PLC is taking an active control of the pump and trying to optimize. The second way that it's the most used, based on my experience, I have seen from the customer, is whenever the customer sets up their field communications. So remember, in the oil field, on the ESPs or any artificial lift systems, everything is about remote locations. So having a good communication system is key to be able to monitor the well. So they have to establish that. Sometimes they can go a third party, or they can build their communication system by themselves. But then they need to install a monitoring system in their side. Normally, these monitoring systems only are for, as the word said, monitor the wells. There is no any closed loop control, and also they rely a lot of the human intervention to be able to analyze the data and then apply changes remotely if the system allows. And the third way of the optimization is whenever the customers use a remote monitoring system like our production link inside. This production link inside provides everything from the well up to the server, so field communications, the connectivity, the data centers infrastructure, and then with our platform, we were able to analyze the data, prioritize events, and then provide recommendations on what needs to be done to optimize the wells. Still, we rely, in engineers to be able to analyze those recommendations and apply them and monitor the results of those. So still, it's a very manual process that needs to be done. The last part that is still we have out there in the oil field is whenever we have wells that are not even connected. So those wells, you can see in the left side of the slide, they only rely in the capabilities of the controller to optimize. So very limited. The results that you will have there are depending on the equipment that you have installed, and the reaction it's very slow. Thank you, Greg.
Good deal, Franklin. Thanks for that input. So Nick, what forms of automation are being used now to integrate with these new systems?
So yeah, I mean, I think if you look at typically what we see today, you know, what we can class as automation. I think Franklin's touched on good points already in terms of what tends to be used. But you know, right now it's fairly basic, right? So we have things like at the well site side again on the left here, we might see things that are quite common in terms of PID loops, so proportional integral derivative, fairly common feedback loop that it's not, you know, specialized for oil and gas, but we use that for being able to maintain a certain operating condition that's desired. So for example, that might be you want to maintain, for ESPs at least, certain amps being used, you know, as the output of the drive. It might be trying to maintain intake pressure, these kind of things. I think that we see, you know, because of the unconventionals increasing, you know, use of expansion of those fields, more and more gas, more frequently we see these kind of control modes, and that gets, you know, looped into these systems that Franklin's referring to. Also down at the, you know, well site side, a lot of good stuff that we have already in our controllers today, as in, you know, some routines that we can run that are very useful again for the conditions of gas with ESPs. So, for example, we have programs that can be triggered on the detection of a gas lock in a pump, that they can run a routine which will break that gas lock and be able to, you know, restore the production. So things like that. But I think in general, right now, it's fairly basic. The tools that we see varies quite widely across the you know, different lift types, different kinds of controllers. But that's generally at the well site side. Again, going over to the sort of central SCADA area, large variety of things that are used there. I think one example is, you know, to streamline the workflow for making the analysis, how to understand and interpret the data. A common thing that's used is to have a digital twin, which can mean different things to different people, but typically that means like a, you know, a physics model that we'll have of the well site, and then we'll be looking at how those calculations differ from what's being measured, and from there we can infer a lot about you know, what's going on. So that you know, it's arguably an automation in the sense of we're helping to smooth, streamline that workflow. But honestly, a lot of, you know, today at least, a lot of things are really based on spreadsheets as well. We think that we're kind of still, as an industry, progressing, but a lot of spreadsheets out there, and I've seen some quite advanced ones as well. But you know, so there's a big mix of different tools, of different software and capabilities. And you know, I think the main thing that when you look at the problem holistically, that we're trying to solve, you know, to get more production, to be able to manage more, you know, operations more efficiently, and lots of great benefits from that. The big thing that's quite apparent is that in terms of technology that we employ, it's, you know, when you look at other industries and even in the consumer space, the technologies you know, that are available to be able to have smart devices and, you know, integration of different elements of networks and workflows, it's really quite advanced, but it's kind of a stark contrast to what we're used to, at least in the field today. Yeah, that's generally how things are right now.
Good deal, Nick. Thanks for that input. Let's move on to our next topic here. So, Franklin, what's your vision, your future vision for production automation?
So the vision of production automation is to change the industry by implementing advanced technology and process to reduce the human intervention. So Nick mentioned, I'm touching in some of them. So we have and there are several key objectives over there. And the foremost is enhanced safety. So in the oil field, safety is the first priority, and with automation, we even can reduce further the hazardous conditions that we have. Right, automation can minimize risks that we have today. For instance, something that we do every day, like just driving to the well site to troubleshoot an equipment. We have to drive like 3 or 4 hours just to get to the well site to do an activity that might, I would say 30% of the time you can do it remotely. So with automation, we can achieve that and also increase operational efficiency. So we can streamline and optimize field operations. Automation can, and I would say will improve the speed and precision of the decisions that we can take and reducing the downtime. So the other portion is increased real-time monitoring and control. Today, we have done great advancements in monitoring, remote monitoring, but still we have a deficiency in how much data we can get from the field because of the communication systems. So we need to improve there. We need to get high fidelity data into our systems to be able to make better decisions and control. We have SCADA systems that we can control settings on the drives, but we need to enhance that. So with that, we will be able to quickly respond to changing conditions and make data-driven decisions as well. So the next is going to be the predictive maintenance. We have seen a good efforts on this one. So how we can use the data that we got from the field to predict, what is the next equipment that is going to fail, and with that we can plan in advance, either a downtime for that equipment or even the materials that are needed to do that. So a lot of things that we can improve. Data integration is another aspect. We have different systems. There is a system to measure production. There is a system to monitor the artificial lift system. There is a system to evaluate the reservoir, but they are not connected yet. So once we have one system that orchestrates all that data together, and with today's technology, like artificial intelligence, we can actually get better insight of the production processing, and we can, make better decisions to optimize the well. Remote operations is going to be another big challenge. So how do we get to the point whenever everything that we do at a location can be done remotely? So there is going to be a lot of needs to instrument the oil field, right? And as well as provide the controllers that can allow you to do that. So that will help a lot in the personal resources. And at the end of the day, all these will help us to enhance reservoir management by optimizing the flow rates that we produce for the wells, and also at the best reservoir pressures. So the data show us that in the future the most production will come from existing wells rather from drilling new wells. As Nick mentioned, there has been a lot of changes in technology in the digital world. We use it every day today. Our phones, our homes. In some industries, everything is fully automated, but we haven't seen that yet in the oil field. So there is a lot of potential in the oil field to automate, and we need to build that system. Our strategy is to have that integrated system that facilitates automated field management and optimization. So this new system will make operations safer, at lower cost, and produce more with fewer emissions. So once we have this system, we will be able to integrate customer databases, field controllers, evaluate in real time opportunities to optimize pumping systems, chemicals, fluids, personal resources, reduce power, just to name a few. And orchestrate in real time changes with minimum human intervention. So that is where we want to get. Even though oil field automation is a big challenge today, I would say the fast growing digital industry is accelerating the adoption of digital platforms. So customers are more open to invest and develop together in automation.
Good deal. Thanks for that insight, Franklin, into what your vision for the future is. So So Nick, where do artificial lift controllers fit in with Franklin's vision for future production automation?
Yeah. So I think kind of going back to how things are today, I mean, they're fairly isolated in how they combine. And so when you look at kind of what's required to realize the vision that Franklin's speaking to, the controllers need to improve. That right now it's a bottleneck in how that communication can happen. It really comes from the controllers themselves that we've kind of, much that hasn't changed over quite some time. So being able to have more intelligent controllers is a big part of how we enable this thing. So some examples of what we can get from that are, when we look at the data that we need to drive these systems, we're looking at AI and big data and much different things that are going on, either from companies such as ourselves or internal customers. To have these systems and these machine learning type techniques, data is important, right? And still a bottleneck to be able to perform those kind of capabilities. Excuse me. So being able to connect better, and also while we have fairly low bandwidth connectivity, and it isn't going to go away, oil and gas, we're still going to have pretty poor communications to remote areas. So having to bridge that gap with those constraints. I think when you look at the general way that these new systems will operate, and being more connected, and the workflows that people do right now, again from those sort of central SCADA enterprise locations, being able to delegate much of the analysis and the control out to the well sites themselves. So much of when you sort of step through the process of how the data gets back to that production engineer or operating person, much of the workload that they have is because there hasn't been much initial data massaging or whatever, or analysis has happened at the well site, and a lot of the control decisions that they have to make can be made right there and then at the well site. So a big part of the overall greater connectivity happens from the well site, and also being able to enable those easier workflows. You need to have controllers which are smarter, able to do those kind of functionality. I think in particular, when you look at ESPs, that's pretty big. I think right now we've somewhat hit the wall in terms of how far we can go with the data that's available. ESPs are very when you want to analyze the conditions of a system and do diagnostics, you're looking at increasingly data heavy inputs. So for example, the electrical signatures, and being able to look at higher frequency behaviors going on, and also to automate some of the controls there, you have to be quite quick and be able to avoid trips and these kind of things. So I think ESPs are a very, very kind of important case for how greater control will be able to smooth the entire workflow. And again, it also goes a bit further afield as well. When you look at what we do right now with chemical automation, being able to increase the integration of our existing systems. And for example, when you apply chemicals intelligently with ESPs, you're able to generally increase the run life, and how that comes together is a big part of its overall vision as well. But yeah, I think in general, being able to have a more streamlined workflow for that end user, again in that central location, and having the devices themselves, the equipment in the field, able to take some of the decisions that they would be making. Of course, it's all kind of tuned for being able to help their jobs. But I think when we look at increased capabilities of controllers, much of the workflow of the entire production operation will improve. Thanks.
Good deal, Nick. Thanks for that insight. So we've got some challenges here implementing artificial lift controllers today. What's Baker Hughes doing to address these problems and move that tech forward going to the future?
Do you want to take this, Franklin, or shall I?
I can take this. So we have been working with key technologies here. I would say let me put some slides over here to show you. We have been working with key technologies to work in this field. We have the Edge unit, that's our computing device, Internet Industrial of Things device. And also we have our new Fusion Pro variable speed controller. And we are working also with the Lucipa. So we are developing the field devices that can enable the automation at the well site, as well as in the cloud or in the customer premises. So with the Edge device, you can actually connect to any existing equipment without the need of replacing the entire equipment. So you can automate and optimize the installation of this in the field. With the Fusion Pro controller, any new well can benefit with the benefits of remote connectivity, permanent and induction motor control that allows power savings to the customer, and as well that optimize the artificial lift systems, optimize the HSNE processing, and together with those two systems, we can optimize the oil field. Nick, you have something to
Yeah, and just to add, I mean, I think that there are some gaps here in from where we are today to get to this vision, right? Some key things to point out is that, one, the communications that we have, the technologies, the protocols are right now pretty basic. So that's kind of the way I see that we build up this vision that we're doing right now is first, communications to be able to be more intelligent, more modern. Again, looking at other technologies that are already out there, and then kind of how we look at what we refer to IoT. So IoT means the Internet of Things, and this is a term to refer to how equipment can connect to each other and also stay online and connected to a central location. And there are systems out there which are kind of what you might term as off the shelf IoT systems that can cater to these kind of use cases. However, when you look at in oil and gas, what does it take to do that? We have certain challenges that are important. I mean, in terms of the remote locations, the personnel, the way that they're used, the commissioning processes, and I think a big thing on how the oil field isn't a thing that's completely static. I mean, over time, sensors change and things get remapped, and things come and go. And this is a kind of a need to customize that often it's off the shelf systems are a little bit hard to do so. So a big thing that we're doing to address this is to be able to tailor technologies that are already out there to bring us all together, and with the right underlying infrastructure, we can service a lot more use cases and a lot more succinctly than is currently possible today. So this is kind of where now we can look at the analytics. We can look at deploying things for the right situation, quite in a far more streamlined way than is currently possible. A lot of remote operations, as Franklin's mentioned, is now possible when we have this. But those are one of the big some of the big gaps. I think as well that when we look at moving towards that kind of closed loop vision, at least to some extent, of being able to take away the decision making and the kind of bottleneck right now that is on the operator side, that's a fairly big challenge in itself. And so we need to have when you look at the automation standards and real sort of secure architecture, there's a way this has to happen in terms of how how control commands are securely passed out to the well site. And again, in our industry in particular, there's a lot of HSE aspects to this. There's being able to make sure that commands are not going to put equipment in an out of range condition and things like that. So a lot of control that has to be in place in terms of the infrastructure that makes it a challenge. But it's a good challenge, and I think that it's very much a vision that we're currently executing. Also, just to mention as well that when you look at the security of this, I mean, there are a lot of, as we mentioned today, the current infrastructure is often a little bit unsecure. And there are vulnerabilities, at least, that are again more and more acute. And to do all of this in a secure way, and to add more more complex controllers and more complex smart devices as part of this, there are new security challenges that come up, and to be able to maintain devices up to date and communication encrypted, all this kind of stuff. There are other elements here that it's a bit of a mindset change, so a challenge there as well. But there are solutions out there that make all of this. Again, if you look at other industries and other kind of technologies which we now adapt as commonplace, much of these challenges that we kind of face, and I think that we are a little bit daunted by as an industry, are already able to be solved.
Good deal, Nick. Thanks for that input. So can you expand more on the challenges of implementing these new components?
Yeah, so I think that there's aside from the technology itself, there is perhaps more of an operational aspect too. So when you think about new technology, it's not always easy to introduce that to oil fields, right? And so making it able to be easily operated by personnel, and also to have the right sustaining infrastructure. So for example, when you look at being able to always stay ahead of security threats, you need to be able to do updates over the air all the time and automatically. And then I think this is a thing that, again, it's commonplace in other industries, but for us, it's a thing that we kind of have to take into account. And particularly when you look at the operational nature of these equipment, we can't have downtime for those kind of updates to happen. You have to be able to have that happening seamlessly. And again, there are all the technology available to do this. It's really about I think one of the biggest challenges is really in a mindset change, and how we're able to easily integrate with existing workflows and existing operational practices. And there is obviously some training required as well. And that's part of the overall shift towards greater digital technology, greater remote operations as well.
Nick, if I can add to your comments here, I would say, based on the equipment that it's installed, changing that the entire equipment is going to be a great challenge. That's where we need to have an optimized approach to deploy the new controllers, so that brings an economical benefit, and regarding the optimization and the cost of the equipment, and that's going to be one of the challenges here. So being able to provide equipment that can fit for that without replacing the entire equipment, that's one. So I would say the other part that I was thinking on this question was remote capabilities and remote locations. So as I mentioned before, that brings a different challenge that from other industries. Other industries have the benefit that have everything concentrated in one facility, and you can see robots working and all the automation going. But in the oil field, everything is remote, so the communication need to be really reliable and secure. So, and also, as you mentioned, we want to have the communications protocols encrypted, so that any data that is transferred from the well site to our platforms or to any of the customer platforms, it's being transferred secure. Another aspect is the communication cost. So we normally use cellular and satellite. Cellular has helped us a lot because it has increased the coverage and also the technology, the data that we can transmit. It's good and a good I would say cost point, but still in all the oil field around the globe there is a small coverage of cellulars in the oil field. So still the only reliable communication system that we use is satellite. And satellite by any means is kind of expensive. So being able to process a lot of the data to optimize at the well site will be critical in those instances so that we don't incur in expensive communication costs. And I would say cybersecurity, you name it, Nick, many times. It's going to change the way that we work in the oil field, right? How we manage, how we configure and operate the equipment is going to be like a learning curve, right? Because it's like things that we do today. It's in the future is going to be minimized because we cannot use, for instance, a USB thumb drive, right? So things like that will make a change. But I would say the benefit of the automation and digitalization will be greater than.
Good deal. Let's move on here. So how is Baker Hughes adapting to meet these challenges? Nick, you want to take that one?
Yeah, thanks. So I think the big thing for us is, firstly, production is a big focus for us as a company right now. But production isn't a product. So it's this is about how we can bring together our existing offerings and enhance those, just to provide the overall production solution for the entire space. And if you look at how we're bringing together some of our key technologies, there's a few mentioned here. I think I've already spoken quite a bit about IoT, so Internet of Things, and how we have that platform that underpins our smart devices as a key part of this. And how we're combining our edge technology with our variable speed drives, and then kind of continuing at the well site, we have tighter integration with existing automations and systems out there. So, for example, I mentioned already that we have chemical control going on there, but when we look at how we integrate those two systems a bit tighter, how we can be able to intelligently apply chemical dosage in keeping with diagnostics from ESPs to be able to generally provide a better run life. A lot of effort that we're able to do on that, and a lot of benefits that we're bringing by integrating those systems together. Also, by having this greater horsepower, so to speak, at the well site, we can do a lot more in terms of diagnostics of ESP operation in particular. So again, the high frequency analysis, the being able to look at the behavior in far more detail of these equipment than we ever could do in the past. So a lot opens up with these additional techniques, and all of this allows us to generate better insights and a lot faster, and then be able to have that come back up to the operator at the central location, where they can act far faster and be able to delegate the automation back out to streamline the overall production operation. I'll add as well that a lot of advancements are being made right now by our digital groups on what kind of in that central location space. So a lot of things that we're doing with our product called Lucipa, which is bringing together much of the workflows and automating a lot of the manual things that we see today in being able to operate artificial lift successfully, to optimize production, to lower emissions, to be able to do a lot of things that right now are not really very feasible, extending run life. And it's all part of that same picture. So again, it isn't like we have one product and no one does. It's all about how do you use these different technologies, different advancements, bring them all together in that holistic solution that we can apply, across the board here, and being flexible too. So, one size doesn't fit everybody. So, some customers are more apt at using the cloud, for example, more keen to do that. Others are strictly on-premise, must integrate with enterprise systems. So a lot of customization that we're taking into account for what customers really need for these systems.
Good deal. Thanks, Nick. So, Franklin, what solutions does Baker Hughes have in place to enable automation with customers' existing equipment?
Regarding existing equipment, we have been working in key technologies. We mentioned Edge, that's our Edge controller that can integrate at any device that is installing in the field. And, with that, we can provide customized automation for those equipments. We also were working with the Veros Foresight technology. This is a technology where we can install any electrical equipment, and its function is to analyze the electrical waveforms that are coming from the motors, voltage, current, and analyze in resolutions that we never seen before. So we thought that, with variable speed drives, we can read the amperage and control from that. But these devices really help us to understand the health and predict any anomaly that could happen in the system. And with that, we can prevent and also predict failures in the future. So that's another technology that it can be installing any equipment regardless of the brand. And the next is as I mentioned before, our Fusion Pro controller. This is the controller that goes in our next generation drive, and has the best in class software that we have developed in the last 4 years of our experience doing controllers, and securely enables digital and automation. So this controller runs in the same IoT platform that the Edge device does. So any application that we develop for Edge can be run in the Fusion controller. So one of the aspects that this new controller brings to the table is remote connectivity. So remote service, and also we have been using this daily. So it has changed dramatically the way that we operate. So during the development process, during the testing, and during the deployment, we have been using this remote connectivity, and has helped us to optimize the operations dramatically. Fusion is part of our next generation drive, and also can be installed on our previous generation. So, that customers do not need to replace the entire equipment. So with that, they can benefit of this new technology in their website. Right? Thank you.
Thanks for that, Franklin. So, got something, Nick?
Yeah, I mean, some just to kind of add to that, some things that we already see that are being done are I think the communications aspect is already a thing that we see a lot of interest in. So again, for moving away from Modbus, for example, as an old protocol that's that's kind of the standard for much of the communications in upstream, and that has been driven by digital transformations for different customer initiatives. So a lot of times that we're seeing that we're able to provide that today, and a lot of our deployments are kind of focused on the communications aspect. We're also again, this is sort of talking to the Edge aspect of being able to retrofit to existing things. We can bring these new capabilities, and then we've been able to, through that same vehicle, do some quite good machine learning techniques that we could never do before, in terms of being able to understand how wells operate and behave as a machine learning process, and through that be able to optimize them in a far more efficient and fast way than essentially is possible by human operation. I think also, just to add, like when we look at the things that we have today, there are a lot of opportunities that come up which are not things that anybody really had on the top of their mind, that are great things that can be automated. A lot of manual data capture, manual kind of integration of systems that maybe are not really that apparent and are just kind of ingrained in our operations. But when you look at it, they're quite easy to be automated when we have these systems in place already, and we're able to quickly write some software that can perform a task in a more efficient way than's currently being done.
Good deal. Thanks for that, Nick. Moving on here. So Nick, while we got you here, could you give us some examples of how these technologies are already being used in the field today?
Yeah. So, I mean, I think kind of just as I've sort of been talking about there, a lot of the communication piece has been quite key. One of the good examples that we're showing here right now is the new controller that Franklin is in charge of, and probably best if I let you talk to this, Franklin, as you're the owner of the Fusion Pro. But it is a great example of how we're combining our technology. So go ahead, Franklin.
Sure, no problem. So yeah, we have been using the Fusion Pro during our pilot phase, to control ESPs in unconventional and conventional wells, running induction motors and as well as PMM to save power for the customers. So one of the key features that we have been using is the remote access, as I mentioned before, and serviceability. So these are functions that we use daily and has shown us great value. Also, it has helped us to optimize the operations from getting real-time data access. So our engineers are able to see from different locations the data, and like in the oil field, everything problem can arise at any time. We have seen power issues as well as well issues, and with the real time, we were able to make decisions, and they were pretty accurate. So that's an example. With this access, we didn't have to travel to location from the support standpoint. All our engineers were connected 100% of the time during the deployment of these units. And also every time, or whenever there is an event that the equipment shuts down, we can quickly identify the issue and provide recommendations. So that helped us to reduce the downtime and optimize the field operations. So the customers have seen this in action, and their feedback has been like, hey, in the way that we are doing today, this compared to how you are doing it, this would really improve our field operations.
Good deal. Thanks for that input. We're going to now switch over to our question and answer portion of the webcast. I want to encourage everybody in our audience to get their questions submitted, so Nick and Franklin get you the answers that you're looking for. Let's take a look at our first question here. An operator already has their own field connectivity infrastructure. Can these new controllers be integrated without replacing the entire system?
I can take that. As I mentioned before, the solutions that we have are designed to actually achieve that, so that you don't need to replace the entire equipment. I would say the edge device will be our first option to go in those instances when it's a device that is agnostic to the brand that it's installed, and we can customize to that equipment. So that is a way to do it. So in the cases where you have legacy equipment from Baker Hughes, from the drive standpoint, we can actually use our Fusion Pro controller to provide that technology as well.
Thanks for that, Franklin. So this question, how do you foresee the field personnel learning curve with this new technology?
I can do that. I think it's probably not as severe as may seem. Again, this is technology where we're actually able to provide a better interface than perhaps is currently available today on much equipment. So there are some things that might be a little bit not what's people used to today, but in general, I think it's actually pretty good. I mean, in terms of the user interfaces and how we connect, being able to use like a tablet or remote access to much of our equipment. A lot of improvements that are coming with this technology that really kind of will make it, I think, a lot easier than people may first think.
Thanks, Nick. So, are there any automated cybersecurity standards being adopted within the industry, like the old WITS-ML and things like that?
I can probably take this too. I mean, one of there are a few. One of the big ones that we see many customers gravitating to, and that sort of driving much of our thinking is IEC 62443, which is a bit of a mouthful, but it's a very comprehensive view of automation security, and this includes not just things like technical protocols and this kind of stuff, but a kind of holistic view of how are these systems being used, including things like operational practices and even training, these kind of things. It's a very kind of comprehensive one, and it's a good one to I think if you're an operator and you're thinking about how can I address this, that's a good one to look at to provide a good.
Good deal. Thanks, Nick. So here's another one. In our operation, we have challenges like shutting wells down due to not having enough power or storage capacity. How would you be able to develop analytics to optimize production or power?
I think we can take this both together, Nick. I would say I can start.
Yeah.
So I would say that the first thing that we need to do is analyze, the challenge that they have, and also being able to integrate all these field into a platform. Understanding we need to deploy edge devices, we need to deploy on-premise platform to be able to aggregate the data, and from there to understand the challenge on we need to use machine learning or artificial intelligence, and then develop that logic. So that's the beauty of the edge device and the new variable speed radar. We can develop that logic for both, and with that being able to optimize based on real-time data. So I don't know, you want to Nick, add something else?
Yeah, thanks. One of the big things that I think the particular question is a good one about the what I interpret as a power quality problem, and we have some technology right now that's able to look at this problem in great detail, again, far more so than we could do in the past. But one of the things that I think is important to kind of get across, that not that this is a great use case in itself of how can we use edge computing, more data to analyze a problem, but when you look at the solution and how can you build trust around a new technology that there isn't really much precedence for. I think Baker Hughes, we're uniquely positioned to be able to solve these issues, and one of the great things that we have is up in Claremore, Oklahoma, we have a great research division there, and things like test wells and all the equipment that we can take a problem like this and we can do extensive testing with all the right equipment. And so when you come to us with these kind of problems, and this is a great one and there are many others, right, we're able to do that kind of great detail of testing and assurance of being able to provide a solution and in a fairly quick way as well. So I just want to point out that we have a lot of capacity to do these kind of solutions.
Good deal. So what's the procedure to update the software on these devices? How complex is it, or relatively easy?
I would say with the new platform, the IoT platform, it's from the user standpoint, it's quite easy, as long as you have access to the platform and all the cybersecurity that was already in place to prevent access from another person that doesn't need to get there. It's quite easy. That is the beauty of the technology today. The things are easier and faster to do. So from the user standpoint, you don't even need to cycle power allocation, for instance, to do this. So everything is done remotely, and that optimizes the operation.
Great. Thanks for that, Franklin. So how does Edge Analytics compare with other PCL programs?
Yeah, I can take this. I wonder if is that like PLCs?
Yes, PLCs.
Yeah, right. So yeah, so that, I mean that's sort of the existing standard for much of the automation at the well site, and I tend to see that PLCs are quite good sometimes at doing very specific things, but when you look at wanting to be more generally adaptable and being able to do more detailed analysis, things like they tend not to have a good time series database, that particularly with things like ESPs, that's very important to analyze data and interpret what's going on in the kind of near term and medium term history of the drive behavior and the ESP behavior. So yeah, I think being able to have more complex analytics, more adaptable, more I think easier to deploy as well. I mean, varies with PLCs, but in general, there are some restrictions on how you can deploy, how you're able to remotely update, and a lot of the new security capabilities are better served by the IoT platforms that we can deliver via an edge system than a legacy PLC platform.
Great, Nick. Thanks for that. So what's the feedback from users on the new remote capabilities?
Oh, the feedback is great. I would say our main customers are our internal users. That our field personnel has noticed the great value of this because it simplifies the support that they get, right? They don't no longer need to download the data, send the data, and that. They just need someone to connect to the well and provide them support. So and also they can do the work even in sometimes conditions that they could probably stop them. Like there was one instance that our technician was at the well site and it rained, right? The location get muddy, and so basically he couldn't walk up to the controller because it wasn't safe. Still, we were able to connect to that and being able to control and make changes through the remote connectivity. That was great. So that's just a few examples on how the users like this, and customers. Oh, they have seen how this can improve their operation. They don't no longer need to wait for someone to arrive to location to start working their wells because they know that now they can actually have someone remotely to do the same activities that they were done at the location before.
Good deal. Hey, we're running out of time here. Nick and Franklin, do you want to give us any concluding statements and wrap this up for us before we sign off?
I think it's an exciting time for technology in the production space, and we're thanks very much for having us on, and it's been a pleasure.
Yeah, thank you. I would say production automation represents a great challenge and opportunity, but I would say the new technology help us to take the production to a new level. So let's work together to develop this technology and deploy it. So contact us if you have any need more information.
Excellent. Thanks for that, gentlemen. We'd like to thank everyone for attending today's webcast. We'd also like to thank Baker Hughes for putting together this timely and informative presentation. Finally, an on-demand version of this webcast will be made available in the coming days and will be emailed to everyone. This concludes today's presentation.